Let's start with a new video, that is function simplification using Karnaugh Map. Before starting the video, I would like to tell you that why we need the function simplification. Okay, so as an IC design engineer or as a customer, what the main requirements are: speed, cost, and power. Okay, so when I take a huge function means it is having many fold of gates. Logic gates will be there, combinational circuits will be there. So if the number of wires are more, so it will take more space. It will consume more power. Okay, if it is bulky, it is taking more power and it is very costly, then its speed is automatically slow rather than a few wires based functions. So we are focusing towards the function simplification, or we can say function minimization, and the techniques that we are using in this video for the function simplification is Karnaugh Map. So we will use K-map to minimize the functions. So what are the learning objectives? After this video, you will be learn how to use Karnaugh Map in simplification of the functions. What are the standard SOP and POS form? What are the canonical form? And how we can convert from SOP to POS and POS to SOP. And the topics to be covered are, first of all, we will discuss what are the SOP, what are POS, how we can represent SOP and POS in canonical form as a main term, max term, as well as what are the main specification, main need of representing SOP or POS, and how we can convert SOP into POS, because in some cases it is required the function should be in SOP. So we need to know that how we can convert SOP into POS and POS into SOP. And at last we will take few examples to show how we can minimize the huge function based on the K-map. K-map will be 2 variable K-map, 3 variable K-map or 4 variable K-map. Let's start with the basic thing, that what is Boolean expression and what is Boolean function. So if I take the case of Boolean expression, so it consists of logical operations performed on the variables which are having the value 1 or 0. 1 or 0 means false or true. Okay, an algebraic form of Boolean expressions. Okay, when I represent the Boolean function in form of algebraic form, means using plus sign, multiplication sign, then it is known as the Boolean function. And Boolean functions can be solved. We can minimize the Boolean function using theorems also. But in this video, I will tell you how to minimize the Boolean function using Karnaugh Map. And Boolean functions can be represented as SOP and as well as POS. If I say SOP, what is it? It is sum of product, and POS is product of sum. Okay, so for representing any Boolean function, NAND gates are required or K-maps are required. Okay, so for simplify or systemizing implementation of Boolean equations, it is necessary to convert it into standardized form. Okay, and I will tell you in the video also that how we can convert in a standard form. So let's start with the SOP part first. SOP, as the name suggests, sum of product, it is known as disjunctive normal form, as disjunctive operation is logical OR operation. So this is the method of simplifying or minimizing the Boolean expression where the variables are operated by AND operator to create the product term, and after that all the product terms are summed up using OR operation. Okay, and the final function that you are getting is known as the SOP representation of the function. And where it is used, SOP functions are mostly used in the reconfigurable computing, as the name suggests, reconfigurable, where we can change the configurations again and again. If, for example, as a design engineer or as a customer, I approach to a company that, okay, I want to design or get fabricated my IC with a specification that it should consume so much power, it should take this speed, it should be this much costly, or it should be having 8 AND gates, 20 multiplexers, these flip-flops, so and so. Okay, the designer designed the IC as per my specification. Afterwards, if I want to get it modified, then in reconfigurable computing, it is easy to change the configuration. We can use the FPGA boards for that. So we can change the configuration as per the requirement of the customer easily. So SOP is used in that case in reconfigurable computing. So let's take a case of example of SOP. So F equal to AB plus AC plus BC. So basically three variables are there, A, B, C, and we are taking the product terms in between these variables. Product term means you are putting a AND operator. Just like BC, AC, AB, these are the product terms. And after taking all the product terms, if you are adding these product terms, means you are summarizing, you are summing up these product terms, the final function is known as the SOP representation. Okay, so it is the SOP representation of the Boolean function, where we are taking the product terms of the variable, means putting the AND operation, then afterwards we are adding up, means we are doing the OR operation. This is the SOP form. So let's move towards the POS, product of sum. So product of sum is also known as conjunctive normal form. Why? Because some terms are ANDed together and the conjunction operator is logical AND. In easy words, if I say that in case of POS, AND operation of all variables are taken place. Means that for example, we are having three variables A, B and C. Okay, so we are taking the OR operation in between these variables first. For example, A plus B, A plus C on B plus C. These are the OR operations in between the variables, and these are individually known as the sum terms. When these sum terms are multiplied with each other, see, we are putting an AND operation in between these variables. The final function is known as the POS representation of the Boolean function. Okay, just like here also, F equal to A plus B into A plus C into B plus C, where A and B, A and C and B and C are the product terms, and the sum of these product terms, okay, is further multiplied, means further they are ANDed to get the final function, which is the POS representation of the function. So further it is the canonical form. So any Boolean function that can be represented as sum of min terms or product of max terms is known as the canonical form. Okay, when the SOP form of Boolean function is in canonical form, each of the product term is known as the min term. Okay, similarly when the POS form the Boolean expression, each of the sum term is known as the max term. So in case of SOP, product term is min term and sum term is max term. So let us see how to find out the min terms of the variable. Now for example, I am taking three variables A, B, C. First of all, how many possible values of three variables are? 2 to power n. If three variables are there, it means 2 to power 3 equal to 8. So total 8 possible values are there, starting from 0 to 7. Okay, so I am representing at 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1 and so on till 1, 1, 1. Okay, so it can be represented as min terms, and min terms can be represented as small m. Okay, so min term, these are the min terms, and let us see, if it is 0, so it will be A bar. If it is 1, it means it is C. Understand this thing, if it is a 0, it will be written as a complemented form, and if it is 1, it will be a normal form. So min term is defined as the product term of n variables in which each of the n variables will appear either in the complemented form or in the non-complemented form. Okay, you understand the thing? If I say 0, 0 means C bar. If I say 1, 1 means C. Here I am representing the same thing as a product term, just like 0, 0, 0. Because all are zeros, so you will write it as A bar into B bar into C bar. Okay, the complemented form is represented as 0 and uncomplemented form is represented as 1. Okay, so because it is a 3 variable function, so having 2 to power 3 equal to 8 values which are in range between 0, 0, 0 to 111. And the minterms of the three variable functions can be represented as M0, M1, M2, so on till M7. Okay, and the values will be either in complemented form or uncomplemented form as shown in this table. Okay, the key summary is that we are taking the values. For example, we have to show two variable minterms, then we will take a, b, x, y, anything. But two variables may have 2 to power 2 equal to 4 values only, 0 to 3, m0, m1, m2, m3. And then we will find out the minterms as according to the values. For example, if I take 0, 1, so it will be a bar, b. 1, 0, a, b bar. Simple thing is 0 means complemented form, 1 means uncomplemented. Okay, so these are the minterms. So if someone asks you what are max terms, so max term is logical sum of all the minterms, logical sum. Now it is known as the max term and it is represented by capital M. Okay, these are represented by capital M. See, here it is 0, 0, 0. Okay, in max term, 0 stands for A and 1 stands for A bar. Okay, here complemented form will be 1 instead of 0 and it will be represented as capital M instead of small m. Small m, min term, capital M, max term. In min term, 0 means complemented, 1 means uncomplemented. But in max term, 0 means uncomplemented and 1 means complemented. Okay, for example, if I take a case of this row, 1, 0, 0. 1, 0, 0 means 4, so it is M4. But 1 means A bar, 0 means B and 0 means again C. Otherwise, we know that 0 is complemented, but in case of POS, where max terms exist, in this case, we have to take the opposite one. Means 0 stands for your uncomplemented form and 1 stands for complemented form. So this is the max term representation of the three variables. Okay. So let us see what are the canonical form of the SOP. Till this point, we have seen that what is SOP, what is POS, what is min term, what is max term. Okay. Now we are starting what is canonical form. So in min terms, all inputs will be either complemented or uncomplemented form. So the logical sum of all the min terms is known as canonical form of SOP. Okay, and it will be represented as sigma small m. Okay, let's take an example also. For example, it is a two variable function ab plus a bar b bar they have given. Okay, min terms, if someone asks you what are the min term is ab and a bar b bar means 1 1 and 0 0. Okay, and when you are taking in form of function, when you are taking logical sum of these min terms, it is becoming a canonical form. Individually, it is known as min terms, but when you are taking the logical sum of all the min terms, it is known as the canonical form. Okay, and because it is a b, a is 1, b is 1, 1 1, it becomes 3. If it is a bar b bar, a bar is 0, b bar is 0, it means 0 0, 0 0 means 0. So canonical form you can write in such a way sigma small m 0, 3. Okay, this is the SOP canonical form of the function. Okay, let's take one more example. For example, the function is y equal to abc plus a b bar c plus a bar b c bar. Question is find out the canonical SOP form. So canonical SOP form can be calculated just like y equal to sigma small m. As I have told you, small m is the symbol of minterms and sigma means we are taking the summation of all the minterms. How to find out these values? Where the normal form is there, put 1. Where complemented form is there, put 0. So it is 1 1 1, 1 0 1, 0 1 0. Okay. So where 1 1 1, 1 0 1, 0 1 0 are the decimal values, just like 7, 5 and 2. And if we say that, okay, represent it in form of canonical form, you will just write y equal to sigma m 257, or you can write y equal to m2 plus m5 plus m7. Here take your thing is small m. Okay. So this is the canonical form of the SOP. Okay, let's take an example. F equal to AB plus A bar B plus AB bar. This is the question. So as the value suggested that it is having only two variables A and B. Okay, now we want to find out the minterms and we have to write the function in canonical SOP form. So minterms, we know that it is AB, A bar B and AB bar. And because it is SOP form, so AB is 1 1, then it is 0 1 and it is 1 0. And if you convert into decimal form, 1 1 is 3, 0 1 is 1 and 1 0 is 2. If I ask you to write in proper sequence, it is 1, 2 and 3. These are the minterms. Now we have to represent it in the form of canonical form. Canonical form is when we are taking the logical OR operation of the values. So sigma small m, okay, then we are taking the values. Here it will be 1, 2 and 3. So it is the canonical form. The sigma small m 1 plus 2 plus 3, or you can easily write as m1 plus m2 plus m3. So these are the canonical form of the Boolean function. So just summarizing the things, that minterms are the individual product terms, and when you are taking the logical OR of the product terms, these are the canonical form. Okay, so as shown in this example also, we are taking the three variables. Okay, just you have to see that which one are complemented and which one are uncomplemented. Okay, if it is SOP, the complemented will be shown as 0 and uncomplemented will be shown as 1. One thing is for clear. And second things are, first of all, put the minterms individually and then take the logical sum of all the minterms. That is your canonical form. Okay, this is all about the canonical SOP form of the function. Okay, so I hope it is clear that what is SOP, what are minterms, what are the canonical form. Now come towards the POS canonical form. Now we are moving towards the POS canonical form. Now let us see what is that. So in product of sum, okay, in maxterm, all the input variables will be either complemented form and uncomplemented form. Same, just like we are talking about in SOP, here also it may be in form of complemented or uncomplemented form. But here the true form x is represented as 0 and complemented form x bar is represented as 1. This is the difference in between minterm and maxterm in SOP and POS. In POS, here 0 means true, but in case of SOP, 0 means false. Okay, the same just like that. In SOP, 0 is complemented form, and in case of POS, 0 means true form, normal form, uncomplemented form. So when we are taking the logical AND between the maxterms, these are the canonical form. These are the maxterms. If I say what are the maxterms are these sum terms, that is A plus B bar. Okay, and it is represented as pi capital M. If you remember, in SOP we represent the canonical form in sigma small m. Okay, but here in case of POS, the canonical forms can be represented as pi capital M and with value 0 1. From where this 0 1 appears, just like take this function f equal to a plus b into a plus b bar. So a is true form, it is not a complemented form, and b is also a true form, it is not a complemented form, but it is POS, it is case of maxterm, so it becomes 0 0. Okay, why? Because 0 means here a is there, so we are taking 0. In case of it is a bar, we will take 1. Just like this case, a plus b bar. Here a is there, we are taking 0, but b bar means complemented form of B is there. That's why it is 1 here. So the canonical form will be pi capital M 0, 1. This is the canonical form. If someone asks you what are the max terms are A plus B and A plus B bar. So this is the POS canonical form. Okay. Let's take an example of canonical POS. For example, a function is given y equal to A plus B plus C into A plus B bar plus C into A bar plus B plus C bar. Okay. Question is find out the canonical POS form. To find out the canonical POS, first of all, we will extract the max terms here. Understand the thing. SOP, min terms, POS, max term. Now the question is POS, so these are the max terms. So how to find out the value of A plus B plus C? It will be 0, 0, 0. Why not I am taking 1, 1, 1? Because it is POS, and in case of POS, A stands for 0. Okay, so it is 0, 0, 0, 0, 1, 0, 1, 0, 1. Okay, after that, taking all these values binary into decimal. Now it becomes 0, 2, 5. And finally, you will represent as y equal to pi capital M 0 to 5. Okay, let's take an example of the same thing. Question is f equal to A plus B bar into this is the function given. It has further many parts. First of all, they are asking that, okay, identify whether it is SOP or POS. If SOP, find out min term. If POS, find out max term. And at last, find out the canonical form of the function. Okay, so again, the very first thing, it is SOP or POS because it is the product of sum. So the first part is solved that it is POS. Okay. If it is in the case of AB bar plus A bar B bar plus AB, then it will be a SOP. Now it is product of sum. It is for sure clear. Now the second thing is find out the max term here. So max terms will be A plus B bar, comma, A bar plus B bar and A plus B. Now we have to write the values here. So A, B bar, A, B bar. So although A is 1 in case of SOP, but here A becomes 0 and B bar becomes 1. Okay, so it is 0, 1. Okay, similarly, it is 1, 1. So this is the case. Further, we can write it as 1, 3, 0. Means I am just converting binary into decimal. So the values are 0, 1, 3. And at last, you are representing it as pi. Because I have told you that it will be represented with pi capital M and then it is 0, 1, 3. It is the canonical form. So it is the canonical form is pi capital M 0, 1, 3. So I am just summarizing the same again that whenever a function is given and asked that find out the canonical form. So very first thing you have to do is you have to extract min term or max term as per the nature of the question. Nature of the question I mean to say is you have to identify whether it is SOP or it is POS. If it is SOP, then it must have min term, then it will be small sigma small m and the values. If it is in the form of POS, then it must have max terms and then what you will do, you will find out the values just like this. Okay, here the things to take care is that in min terms, when the case of SOP, A bar means 0 and A is 1. But in case of POS, that is your max term, A stands for 0 and A bar stands for 1. So this is the case This is how you can find out the values. The things to take care is that in case of your SOP, we are taking sigma small m, but in case of your POS, we are taking pi capital M. Okay, so till this point, we have seen that what are the POS form, what are the SOP form, what are min terms and max terms, and how to represent the canonical form of function. Okay, the things to take care is that don't get confused with the min term and max term. Min term exists in SOP and max term exists in POS. So after canonical form, the main important thing is the standardized form. Okay, because standardization makes the evaluation and implementation of the Boolean expressions easy and systematic. So it is required that the Boolean function will be standardized. Okay, now understand what is standard form of the Boolean function is. If I say standard form, so standard form is where all the variables are involved. When I say all the variables, it means that, for example, it is 3 variables. Then all the 3 variables A, B and C should be involved in the individual terms. Okay, it may be the complemented form or in the uncomplemented form, that does not matter. But the presence of each and every variable in each term is must. If all the variables are not present in each and every term, it means it is a non-standard form. Okay, if it is any variable is missing, so it is not a standard form. Okay, so all the min terms or max term should contain all the variables in any form. Form does not matter whether it is complemented or uncomplemented. Whether in the case of min term or max term, all variables should be there. Then it is known as the standard form. So see what are the rules if it is standard or unstandard, how to proceed further. So let's take a case where the A is missing, means we are taking a case of 3 variables where A is not present. So what you will do, first of all identify which variable is missing, then take it A plus A bar and multiply with that function. Why I am taking A plus A bar? Because A plus A bar is 1, and when we are multiplying the function with 1, it is the same function. Okay, you understand the thing? For example, if I say the case is y equal to A, B, C, okay, plus A, B. This is the case because it is the standardized SOP form. So what we will do? The very first thing you will do is you will see that in first term it is ABC, means this question involves 3 variables. This is first term, this is second term. First term has all the 3 variables, but in case of second term, the C is missing. Okay, so missing variable is C. Then what you will do, you will multiply this thing with C plus C bar. Okay, what I am doing? I am just making it standardized form. See, question was ABC plus AB. ABC means all the 3 variables are there, A, B, C. Okay, well and good. But here C is missing. Because C is missing, it means it is not a standard form. It is unstandard form or it is non-standard form. So what you will do, you will identify which variable is missing. Okay, we have verified that C is missing. Now what I will do, I will multiply this term with C plus C bar. Why I am doing so? Because C plus C bar is 1 and AB into 1 is AB. But my smartness is I want to include C in this function. So the function will become y equal to ABC plus ABC plus ABC bar. Okay, then we will put the Boolean laws that A plus A equal to A. So it will be ABC plus ABC bar. That is the standardized SOP form. Okay, so in such a manner you can convert it to a standardized SOP form. So rule says first of all see how many functions for variable it has. Then after checking the number of variables, then check out each and every term individually. whether it has all the variables or not. Okay, if in first term C is missing or B is missing or A is missing, just multiply that term with the missing variable plus complemented of that missing variable. Because we know rule says A plus A bar equal to 1. So if missing is D, it will be D plus D bar multiplication. Okay, just like this question. ABC plus BC. Now we are multiplying with A plus A bar. Okay, now it becomes ABC plus A bar BC. Now what happened when you are opening the bracket? It is becoming ABC plus ABC plus A bar BC. Okay, although it is a standard form, but we are seeing that two ABCs are there, means duplicacy of same term is there, ABC and ABC. Again, the Boolean law says A plus A equal to A. So ABC plus ABC equal to ABC. Okay, so we are taking ABC just once. So it is ABC plus A bar BC. Okay, now this is the canonical form, and now we will convert it into the form of sigma small m, means we will extract the min terms out of this and write in desired canonical form. Okay, although you can write the canonical form from here also, because but the problem will be here 1 1 1 1 1 1 will be twice. At last step you have to take it once. So we are minimizing the step, we are minimizing the function here only by putting the Boolean laws. So y equal to ABC plus A bar BC. Now because it is SOP, it has min terms, so it will be 1 1 1 0 1 1. So 1 1 1 is 7 and 0 1 1 is 3. So you can represent it as y sigma small m 3 comma 7, or you can write m3 plus m7. Okay, so this is the case when any function is given and you have to write that function in form of standard form as well as in form of canonical way. Okay, so first of all, check out how many function variable it is. They are suggesting that ABC is there, so 3 variable function is there. Okay, then but in second term, because A is missing, we multiplied with A plus A bar, then putting the Boolean laws, and finally we are getting the standardized form as well as the canonical. So it is the example of standard SOP. Now the case is standard POS. Again, the basic fundamental rule is same. Standard means where in the function each and every term should have all the variables present. Means for example, the function is 4 variable A, B, C, D. So each and every term should have A, B, C, D inside it, whether it is complemented form or uncomplemented form. That is not an issue. Now see, just like this function y equal to A plus B plus C into A plus B. Now what is happening over here? In A plus B plus C, it indicates that there are 3 variables. But in this thing A plus B, now C is missing. So the second step is you have to identify the missing variable. Because missing variable is there, so it indicates it is a unstandard form. That's okay, but we have to make it standard. So first of all, find out the missing term. So the missing term is C. Now what you will do, you will add the value missing term into complemented of missing term. See this thing, CC bar. Why CC bar? Because when I say that, okay, I will add CC bar to this thing, it will be just like 0. If I add 0 here, it will the same thing. A plus B plus 0 is A plus B. So further you can write it as A plus B plus C into A plus B plus CC bar. So this is the case. Okay, I hope it is clear that first of all you are taking the function, then we are identifying that which are maximum number of variables. Okay, 3 variables are there, A, B, C. Now C is missing in this part. Because C is missing, so we are just adding the value, missing value into the complemented form of that value. So it is A plus B plus C into A plus B plus CC bar. Then put the distributive law of the Boolean function and then open the values. Open the values means because it is a POS, so A bar means 1 and A means 0. Okay, distributive law says x plus yz equal to x plus y into x plus z. Okay, just like A plus B plus C bar, so you will be A plus B plus C into A plus B plus C bar. So repeat the same step again and again until you are getting all the variables in the function. If all the variables in the function are present, it makes it as a standardized POS form. Okay. So let's take the second example of the standardized POS form. Before processing further, just I want to summarize the thing that in POS, if any variable is missing, simply say it is an unstandard form. Second thing, identify the missing term. Third thing, missing term into the complemented of missing term. Now that thing just add to the term where the missing variable was there. Now open the things using distributive law property and then gives the value. Now let's take an example of the POS form. See, this is the function given is A plus B plus C into B bar plus C. See, this is the question. Okay, now what happened? First of all, identify whether it is a standard form or non-standard function. So it is A, B, C. Okay, it indicates that 3 variables are present in the question. But in this part, only B and C are there. A is missing. So we have identified that it is a non-standard function. And second thing, we have identified that in second term, A is missing. Okay, now what you will do? You will multiply this term with A bar. Okay, it will be A plus B plus C into A bar plus B bar plus C. Because A bar is 0, 0 plus something the same value. Now using the distributive property, you will open the brackets just like this thing. So A plus B plus C into A plus B bar plus C into A bar plus B bar plus C. Okay, just like putting the distributive property of Boolean laws. Now you see that 3 terms are there, 1, 2, 3. Now we will check whether each and every term has all the values or not. So here 1, 2, 3, A, B, C are there, A, B, C are there, A, B, C are there. We don't mind that whether it is a complemented form or uncomplemented form, but it should be in form of all the variables A, B and C. Okay, so this is the thing. It is a standard POS form. So y equal to, now we are writing in form of canonical. So y equal to pi capital M. We are writing this standard function in canonical function. Okay, so how to write the standard function into canonical function is, you will just write the values in the binary format. Just like this thing, because A is there, so it will be 0. Okay, so it will be B bar, it will be 1. Okay, so B bar stands for 1 and A stands for 0. Why it is so? Because it is a POS and POS means A stands for 0 and A bar stands for 1. So we are converting it as 0, 0, 0, 0, 1, 0, 1, 1, 0. Okay. After that, y equal to pi capital M, it is 0, 2 and 6. Okay, write in the desired canonical form. So desired canonical form will be this thing. M0, M2, MC, 6 in the multiplication form. So these are the desired canonical form. So this is the case, means how we can convert SOP POS into standard form and to the canonical form as well. So I'm just concluding the video that in this video we have learned that how to write SOP in standard form, canonical form, and how to identify the missing terms, how to make unstandard into standardized form. So that's all about this video. We will meet again in the next video.